In this video, I want to have a look at finding the surface area of composite solids. So we're just going to have a look at one example. So here we've got a cylinder with a hemisphere sitting on top of it. So if we look at the formulas that we have, first the surface area of a sphere would normally be 4 pi r squared. But we've only got a hemisphere, so we can write half times that to get half of it, or because half times 4 is 2, we could just replace that with 2 pi r squared. So that's the hemisphere that's on the top of our shape. Now we need to look at the cylinder that's underneath. So as well as that, we would normally, for a cylinder, have 2 pi r squared plus 2 pi rh. So this part of our formula here finds the circle that's on the bottom and the circle that's on the top. But in our example, that circle that's on the top isn't actually part of the surface of our shape. So we only need pi r squared, not 2 pi r squared. This 2 pi rh finds the curved surface that wraps around the edge of our cylinder, which is part of our surface, so that's going to be fine. So this is the formula that we're going to use for this shape. So what that's going to become when we put in all our numbers is going to be 2 pi times 17 squared, because that's our radius, plus pi times 17 squared, plus 2 times pi times 17 times our height is 25. And when you pop that all into your calculator, if we round it to one decimal place, we'd end up with 5,394 centimetres cubed. So it's really important when you're doing these that you are looking to see how the formulas that we usually use apply to these sorts of questions, especially when there's joints between two different shapes. But that's one example of finding the surface area of a composite solid.